Hello, Algebra 1 students. Welcome to Lesson 6-4, Video 1 on geometric sequences. So, back in Topic 3, when we talked about linear functions, we talked about arithmetic sequences, which were very similar to linear functions. Well, here, geometric sequences, these are in the exponential function topic. So, I would assume that geometric sequences have to do with exponents and exponential functions. So, let's dive in and take a look. Example 1. Identify arithmetic and geometric. Is the sequence an arithmetic or a geometric sequence? So here it is. 3, 2, 4/3, 8/9, 16 27ths. So understand that when you're talking about a geometric sequence, you're looking for a sequence in which each term after the first term is found by multiplying the previous term by what's called the common ratio. So we're not looking for a common difference, it's a common ratio. Okay? So typically when you do ratios, you're going to divide, right? So to figure out what this common ratio is, we're going to take the second term, 2, and divide it by 3. Well, 2 divided by 3 is 0.6 repeated. Okay? Then we're going to take the third term, 4/3, and divide it by 2. Okay? So this is just 2 over 1. Again, you could have just typed it in Desmos and got the answer. I'm going to try to show you. So instead of dividing by 2 over 1, we're going to multiply by the reciprocal. So this is 4/3 times 1/2. Multiply across the tops and the bottoms. That's 4/6, which does simplify to 2/3, which is also 0.6 repeated. So we have a common ratio so far. Let's do the same thing with 8/9. So take 8/9 and divide it by 4/3. Again, we're going to take 8/9 and multiply by the reciprocal of 4/3, which is 3/4. We're going to multiply straight across. That's 24 over 36. And both of those are divisible by 12. 24 divided by 12 is 2. 36 divided by 12 is 3. That is also 2/3, which is 0.6 repeated as a decimal. And last but not least, 16 over 27 divided by 8/9. Again, take 16 over 27 and multiply by the reciprocal, which is 9 over 8. Okay, this gets kind of big numbers. So what I want you to think of is the following, right? Think of this as 16 times 9 on the top, 27 times 8 on the bottom. We're going to cancel out some common factors, right? This 8 and 16, we can actually divide. Right? 16 divided by 8 is 2. 8 divided by 8 is 1. The 9 and 27, we can do the same thing. Divide by 9. 9 divided by 9 is 1. 27 divided by 9 is 3. So instead of multiplying it all out and then simplifying in the end, simplify before you do the multiplication. And again, this is just extra work. All you got to do is type this into Desmos, and you'll get the answer, right? Or you'll get the decimal version. But this is also 2/3, which is 0.6 repeated. And if you notice here, in between each pair of consecutive terms, the common ratio is this 2/3. So this is a geometric sequence. And the reason it's geometric because it has a common ratio of 2/3. And we want to keep the fraction. We don't want to use decimals if we can avoid it. So there you go. Okay. Once you start seeing these fractions, right, I would assume you're thinking geometric. Arithmetic, remember, it was like common difference. So like the difference between 3 and 2 is going down by 1, right? But then between 2 and 4/3, that's not going down by 1, obviously. So it's not going to be arithmetic. Okay. All right, cool. So next. Okay, is the sequence an arithmetic or geometric? So now here, if you notice, now we do have decimals. But notice, like, they're kind of all similar numbers, right? 3, 4.5, 6. So I'm thinking maybe arithmetic to begin, right? So how do I go from 3 to 4.5? So you can know what you're adding by, or you can take the second term and subtract the first term. That's 1.5. You can take the third term, 6, and subtract 4.5. That's 1.5. You can take the fourth term, 7.5, and subtract the third term, 6. That's 1.5. You can take the fifth term, 9, and subtract the fourth term, 7.5. That's 1.5. So every time it's increasing by 1.5. So this is arithmetic, actually. So this is arithmetic, arithmetic, and it has a common difference, if you recall from topic 3, a common difference of 1.5. And there we go. So that's the comparison between arithmetic and geometric. So be aware of how we figure out each one. Okay, so now it says, what is the recursive formula that describes this geometric sequence? So they're telling us that this is geometric, but they want the recursive formula. So here it is right here, right? A sub n equals r times a sub n minus 1. Right? So this is where we take that common ratio and multiply it by the previous term, a sub n minus 1, and that gives us the next term, a sub n. Remember also, they usually want you to identify the first term. So remember, a sub 1 is the first term. So make sure we also include that. Okay, so if I look here, so here is my geometric sequence. So right now I know my first term. My first term is 8. And now we need to find that common ratio. Well, let's take the second number, 12, and divide by 8. Again, you can get a decimal, but try to use fractions, right? If you do the decimal and Desmos, just press the fraction button. But here, we're going to divide both by 4, and that's going to be 3/2. And that's my common ratio. So my recursive formula, a sub n equals 3/2 times a sub n minus 1. Now, again, just to test this out, right? Just to test, let's find what the fourth term. So 27 is the fourth term. So let's let n be 4. So a to the fourth equals 3/2 times a n minus 1. 4 minus 1 is 3. So we're going to take 3/2 and multiply by this third term. The third term is 18. So the 18 just multiplies to the top. That's 54 over 2, and 54 over 2 is 27, and that checks out. So that's how we use this recursive formula to take a previous term and find the next term, right? So 40.5, that's the fifth term. We could find the sixth term using the 40.5 and 3/2. Okay, good deal. All right, last one on this video. Now we're going to talk about the explicit formula. So now it says, what is the 10th term in the sequence using the explicit formula? Now, when we do explicit, that's where we can use any n value, right? Any nth term we can find. Here's your explicit formula. A sub n equals a sub 1 times r to the n minus 1, right? So we, again, know our common ratio from last time. It's 12 over 8, which is 3/2. So to find a sub n, we need to take the first term. The first term in our sequence is 8. And we're going to multiply it by 3/2 to the n minus 1. This is my recursive formula. Or, I'm sorry, this is my explicit formula. I apologize. So now if I want to find the 10th term, we're letting n be 10. A sub 10 equals 8 times 3/2 to the 10 minus 1 power. Now 10 minus 1 is 9. And you're just going to type this in Desmos. I'm going to go to Desmos and show you how to type it in. So 8 times 3/2 to the 9th. So 8 parentheses 3/2. Oh, sorry, close parentheses, raised to the 9th. Remember, you can use the caret button, which is above the 6, so shift 6. And there we go. This is your estimate for the 10th term. So a sub 10 equals, and again, 1 or 2 decimals is fine. I'm going to do 2 decimals. So it's 5/4. The 6 is going to round this 4 up to a 5. So we'll do 307.55. And that's our 10th term in this sequence. Okay? All right, thanks for watching the first video. Second video is coming right up next.